In this video, we're going to look at rearranging equations, or if you like, changing the subject of an equation. We're going to start off by doing some revision on solving equations. The reason we're going to do this is that we'll use very similar techniques to make a variable a subject of an equation. So, for example, now here we have 2x minus 1 is equal to 5. We're looking to solve these equations for x. We might have 2x minus y is equal to 5, and we would need to make x the subject. So let's go ahead and just solve this equation. So 2x minus 1 is equal to 5. The way I like to do this is simply by adding 1 to both sides. So if we add 1 to both sides, we'll get 2x is equal to 6. And then I like to divide both sides of the equation by 2, and that would give me x is equal to 3. I wouldn't necessarily write these things down in my working, I'm just simply showing what I'm doing here. So what I've done here is made x the subject, and in this particular case it just gives us a number. Let's say we had an equation 2x minus y is equal to 5. This time instead of the minus 1 I've got y. I might be asked to make x the subject of this equation. What I did here is try to get the x's on the one side and anything without an x onto the other side. So I'm going to do exactly the same here. I'm going to add y to both sides of the equation. So 2x is going to be equal to y plus 5, or 5 plus y, either way around. I'm going to write it as y plus 5. And then we would simply divide the equation by 2. So y plus 5 divided by 2. So x is now the subject of this equation. So here we saw it just gave us a number or a value. Here this is now expressed in terms of y. So we would say that x is expressed in terms of y. If we have this equation again, let's write it out. 2x minus y is equal to 5, and we wanted to make y the subject, then I could look at getting y on this side and then anything without a y on the other side. So what I'm going to do at this stage is add y to both sides. So 2x is equal to y plus 5. And then I'm simply going to subtract the 5 from both sides. 2x minus 5 is equal to y. So you can see we're doing exactly the same here. All we have now, instead of a simple numeric value, is now another expression with a different unknown or a different variable. We're using exactly the same techniques to now rearrange as we would to solve equations. So this one just here. So 2x minus 1 divided by 3 is equal to 5. I'm going to write what I'm going to do. You certainly don't have to do this. I'm going to multiply both sides of this equation by 3. In doing so, I'm going to clear the fraction, and it will allow me to isolate this term in x. So that will give me 2x minus 1 is equal to 15. I'm now going to add 1 to both sides of the equation, so 2x will be equal to 16. I'm now going to divide both sides of the equation by 2, and that's going to give me x is equal to 8. Remember, this equal sign means now that we have to do the same to both sides to keep the equality, and that's why I'm writing it like so. The reason I'm doing this is because often lower down when you're solving equations, often we're told to work backwards. So for example, if I had this equation, what we would do is add 1 divide by 2. That's what we're doing. But if we have unknowns on both sides, we can't simply work backwards in that way. And that's why I like to say I'm doing the same to both sides of the equation. Okay, let's look at this one just here. What we've got is 5 multiplied by the quantity 2x minus 1 is equal to 15. I could expand the brackets out here, or I could divide both sides of the equation by 5. The reason being is 5 is a factor of 15. 5 goes into 15 3 times, so I would have now 2x minus 1 is equal to 15 divided by 5, which is 3. Adding 1 to both sides, 2x is equal to 4. Dividing both sides by 2, x is equal to 2. Let's just check that works. Well, let's substitute in. If x is 2, 2 times 2 is 4, minus 1 is 3, 5 times by 3 is 15. So we can see that x is equal to 2 is a solution, or the only solution to that equation. This one right here, again, I could expand the brackets out if I wanted, but I certainly don't have to, as we can divide both sides of the equation by 5. If I did that, I'd have now 2x minus 1 is equal to now 2 lots of 3x plus 1. I need to multiply the brackets out on the right hand side. 2x minus 1 is equal to 6x plus 2. I now have unknowns on both sides, so I have now a term in x on both sides. I want to collect the x's on one side, so I'm going to subtract 2x from both sides. In doing so now it will leave me no x's and just the negative 1 over here, and then we'll have 4x's plus the 2 over here. I want to isolate this term in x as I'm trying to solve for it, or make it the subject of the equation. So at this stage, anything without an x I want over the other side. So I'm going to subtract 2 from both sides of the equation. Negative 3 is equal to 4x. I just want 1x, so I'm going to divide both sides of the equation by 4, and that gives me that x is equal to negative 3/4. Don't be concerned that that isn't an integer or a whole number. Often it won't be the case. We could of course check that. I'm pretty confident it works, but if you wanted to, you can substitute back in. Okay, let's look at this one. We've got now 2x squared minus 1 is equal to 17, and we're looking to solve for x. This is an example of a quadratic equation, as we've got now the highest power of x as a squared term. So x started its life off, it got squared, it was then multiplied by 2, it had 1 subtracted, and that became 17. So let's write this out. 2x squared minus 1 is equal to 17. Adding 1 to both sides, 2x squared is equal to 18. Dividing both sides by 2, x squared is equal to 9. And now we need to take the square root of both sides of the equation. X will be equal to plus or minus the square root of 9. So x will be equal to plus or minus 3. Remember, if we do negative 3 multiplied by negative 3, this gives us 9. 3 multiplied by 3 also gives us 9. So if we're taking the square root now of 9, we need a plus or minus in front of our square root. Okay, let's finish off with this one right here. This is a cubic equation as we got the power of 3. We wouldn't look to expand this bracket out as we probably don't have the skills to do that. What I'm going to do with this one is just write it out. 2x minus 1 all cubed is equal to 27. I'm going to take the cube root of both sides. Taking the cube root of this clearly will remove the cube term, and taking the cube root of 27 will give me 3. 2x minus 1 is going to be equal now to 3. Adding 1 to both sides, 2x is equal to 4. Dividing both sides by 2, x is equal to 2. So that's what we've got. Now let's look at this if this was actually now 2x minus y. So 2x minus y all cubed is equal to 27. At this stage, if I wanted to make x the subject of the equation, so I wanted to express x in terms of y, which could just be y and a few numbers, or it could just be y, we would do exactly the same. I would take the cube root, so 2x minus y is equal to 3, so we're exactly the same here. I would add y to both sides as I just want terms in x on the left hand side, and then I divide both sides now by 2. So x would be y plus 3 over 2. So I've done exactly the same, but we don't have a nice numeric value. We have x in terms of y, or if you like, x is the equation. It's the subject of the equation. You could, of course, at this stage made y the subject if you were asked to, and we would simply add y to both sides and subtract 3. That's making y the subject of the equation. What we're going to do in the video is look at some very basic examples using these techniques, and then we're going to go on to some more challenging ones. So let's start off. In question 2, we're told the equation v is equal to u plus at is used to find the velocity of an object. Currently, v is the subject of the equation, so we can see v is expressed in terms of u, a and t. We're asked in part A to make u the subject. So what we've got is v is equal to u plus at. So what I want now to make u the subject is have u on one side and everything without a u on the other side. Now if we just consider, all we've got here now is this plus at. So for example, if I said now 3 is equal to x plus 1, and we wanted to find x, we would simply subtract this 1 from both sides, and x would be 2. So that's exactly what I'm going to do. v minus at is equal to u. u is now the subject of the equation. It doesn't matter that it's on the right hand side. I could of course write this as u is equal to v minus at. So that's what we would have. We now want to make a the subject of this equation. So starting back, v is equal to u plus at. at is telling me that it's a multiplied by t. So for example, if we had 3x, this is telling me it's 3 multiplied by x. So what I need to do is make a the subject. So what I do to begin with is get everything now on the right hand side that doesn't have an a onto the left hand side. So that will become v minus u is equal to a multiplied by t. I don't want a times by t, I just want a to be the subject. So it'll be v minus u divided by t is equal to a. Now we have a as the subject of the equation. We want to make t the subject. So back to the beginning, v is equal to u plus at. It will be exactly the same process here. So we need to subtract the u. That will give us a multiplied by t. Then we simply divide now. v minus u divided by a is equal to t. t is the subject of the equation. T in this particular case is the time. So for example, you might want to now find the time given this, which is the final velocity, this one, which is the initial velocity, and this now, which is the acceleration. So we can rearrange equations to find now, in this particular case, we can find the final velocity easily as v is the subject. With this one, we can find the initial velocity, u, as now the subject of the equation. This one we could find the acceleration easily, and this one we could find the time. So that's the advantage of being able to rearrange an equation. This is no different to solving an equation like so. So if we look, for example, now if we said 4 is equal to 1 plus 3x. This now is very similar right here. If I wanted to now solve for x, it would be 4 minus 1 is equal to 3x, and then 4 minus 1 divided by 3 is equal to x, and we can see that that's just going to give us 1. 4 minus 1 is 3, 3 over 3 is just going to give us 1. At this stage though, of course, we don't know the value of v, u and t, we're not told it in the question, therefore we can express a in terms of those other unknowns or variables, rather than just solving an equation for a numeric value. Okay, in question 3 we're asked to make x the subject of the following equations. So the first one, y is equal to 2x. I want 1x. So all I'm going to do here is simply divide both sides of the equation by 2. So if y is equal to 2x, we can say that y divided by 2 is equal to x. And I've made x the subject. Currently, y is the subject. Here, x divided by 2 is y. The inverse operation of dividing is multiplying, or if you like, you could divide both sides by half. It really doesn't matter. X would be equal to 2y. So now we've got x as the subject of the equation. This one just here, x divided by z is equal to y. We don't want x divided by z, we want x. So we simply multiply both sides of the equation by z. Or if you like, you could say you're dividing both sides of the equation by 1 over z. I think it's easier just to say multiplying. So x is equal to yz or zy. You might want to write this in alphabetical order rather than zy, yz. If we consider now 3 times by 2 is 6, 2 times by 3 is 6, and we can see now that the order in which these letters appear with multiplication doesn't matter. Okay, let's now look at this one just here. We've got y divided by x is equal to z. I can multiply both sides of the equation by x, so I get y is equal to x multiplied by z, and then simply divide both sides of the equation by z, and that would give us x is equal to y divided by z. If we think now, if we had 1 over x is going to be equal to 2, then what we can see now is that that is clearly going to be 2. So here we'd have 1 over 2 is equal to x. We'd simply multiply up and divide down. That's what we've done here. Okay, this one we've got now x divided by 3 minus 1 is equal to y. So currently y is the subject, we need to make x the subject. I'm going to add 1 to both sides of the equation. X divided by 3 is equal to y plus 1. And I'm going to multiply now both sides of the equation by 3 to now express x in terms of y. What we need to be careful here is that we do 3 lots of the quantity y plus 1. This is not, now x is not, and we use this as not, it isn't 3y plus 1. We're multiplying the quantity y plus 1 by the 3. Okay, let's do this one. There are a couple of different choices with this one. You might want to consider now adding and subtracting or multiplying and dividing. More intuitively here, instead of subtracting 1 and multiplying by negative 3, I'm going to add now this expression to both sides of the equation. You certainly don't have to, but it might make your life slightly easier. So what we have now is the following. I've got 1 minus x over 3 is equal to y. Therefore, adding the x over 3 to both sides of the equation, I now have this scenario. At this stage, I can subtract y from both sides, and that now leaves me on the right-hand side a positive term in x. I simply need to multiply both sides of the equation by now the 3, and that will give me that x is equal to 3 lots of 1 minus y. Okay, if I'd done this differently, what I could have said now is negative x over 3 is equal to, and subtracting 1 from both sides, y minus 1. At this stage, I could have multiplied both sides of this equation by negative 3, and that would have given me negative 3 lots now of y minus 1. These two expressions now on the left-hand side here and the right-hand side here look different. They are not. If you multiply them out, x would be equal to negative 3y plus 3, and here x would be equal to 3 minus 3y, which are of course the same. I just think for this particular example it's more intuitive now to make the x positive by adding it to both sides. You can though multiply both sides of the equation by negative 3 here. You can do it step by step. I just think it's more intuitive to rearrange in this particular way. Okay, let's now look at the next one. At this stage I've got now 2 lots of x minus 1 is equal to y. The temptation here is to expand the brackets out. I'm not going to do that as I'm making x the subject. I'm simply going to divide both sides of the equation by 2. That now gives me the quantity x minus 1 is equal to y divided by 2. I'm going to add 1 to both sides, so x is going to be equal to y divided by 2 plus 1. And that now is making x the subject. If you wanted, you could combine this fraction, so we'd have now x is equal to y plus 2 divided by 2. That's by getting a common denominator. If I wrote an equivalent fraction, 1 is 2 over 2, so it's y plus 2 over 2. If you'd expanded this out, you would have had 2x minus 2 is equal to y. Adding the 2 to both sides, 2x is equal to y plus 2. Dividing both sides of the equation by 2, y plus 2 divided by 2. I strongly suggest, unless you have to, don't multiply out, simply divide now both sides of the equation so you can get to those brackets. Okay, let's look at the next one. Not going to expand this out, so we start with 2 lots of 3x minus 1 is equal to y. If we look at this now, what we've got here is simply the same thing above, but when we come to the term in x, we're going to have to divide by the 3. You could argue that expanding the brackets out here will help you in terms of how tidy this looks. I'm simply going to divide both sides of the equation now by the 2. So 3x minus 1 is equal to y divided by 2. I'm going to add 1 to both sides. 3x is equal to y divided by 2 plus 1. And I'm going to divide both sides of the equation by 3. Y divided by 2 plus 1 all over 3. That looks a bit messy. If we combine these fractions, this would be y plus 2 over 2 divided by 3, and we could write this, if we wanted, as y plus 2 divided by 6. If you don't like doing that, you could have argued that it would have been easy enough to expand the brackets. 6x minus 2 is equal to y. Adding the 2 to both sides, 6x is equal to y plus 2. Dividing both sides of the equation now by the 6, we got y plus 2 divided by 6. And you can see we have exactly the same thing. Right, with the next one, we've got exactly the same here, but it's just y plus 1. So, if you want, you can expand the brackets, or you can simply divide through. So if I divided through, 3x minus 1 is equal to y plus 1 divided by 2. Adding the 1 to both sides, 3x is equal to y plus 1 divided by 2 plus 1. And then dividing both sides of the equation by 3, we have y plus 1 divided by 2 plus 1 divided by 3. And that looks very messy. Again, if you wanted, you could have expanded it out. Now, at this stage, I'm just looking at this and saying, well, that's going to be 2 over 2. Then we've got y plus 3 over 6. But if your work with fractions isn't as strong and you don't want to combine this fraction and then divide by 3, you don't have to. You can expand out. The more problematic these get, though, the neater your work is if you can divide. And certainly if there are numeric values, dividing by common factors. So just combining this fraction, as I'm going to do it the other way, we'll have now y plus 3 divided by 6. So let's look if I'd expanded it out, very similar to the last one. We would have had 6x minus 2 is equal to y plus 1. I would have added the 2 to both sides. 6x is equal to y plus 3. Dividing both sides by 6, x is equal to y plus 3 divided by 6. Okay, let's move on and look at some more. Okay, this one right here. So on the left-hand side, we've got y minus 3. On the right-hand side, we've got 2 lots of 3x minus 1. I'm going to go ahead and divide both sides by the 2. So y minus 3 divided by 2 is equal to 3x minus 1. Add in the 1, y minus 3 divided by 2 plus 1 is equal to 3x. Dividing both sides of the equation, y minus 3 divided by 2 plus 1 by the 3, that will give us x. And again, if you want, you can tidy that up. You might even spot a link between some of these and just simply make a substitution. We'll leave this one here because this is just very similar. I would simply add this. No, in fact, we will do it. Right. Y minus 2 lots of 3x minus 1 is equal to 1. I'm going to add this expression to both sides. So y is going to be 2 lots of 3x minus 1 plus 1. I'm going to subtract the 1 from both sides. Y minus 1 is equal to 2, 3x minus 1. So we're now in a very similar position, if not an identical position, to one of these earlier. At this stage, you can multiply out or you can divide through. This time I'll multiply out. Y minus 1 is equal to 6x minus 2. Adding 2 to both sides, as I want to make x the subject, y plus 1 is equal to 6x. Dividing both sides of the equation by 6, y plus 1 over 6 is equal to x. Now x is the subject. We can see at this stage now if we wanted to make y the subject, we simply would have added this expression to both sides. So y would have been equal to 1 plus this quantity of 2 lots of 3x minus 1. Moving on. Here now we've got some division. At this stage, all I'm going to do here with this one, y minus 1 divided by x is equal to 5. I'm going to divide both sides by 5 and multiply both sides by x. If you consider now what's going to happen, I'm simply going to swap their positions. So if I multiply both sides by x, it would clear this fraction, leaving me y minus 1 is equal to 5x. I just want 1x, so I'm going to divide the quantity y minus 1 by 5, and that will give me x. So all I've done is simply swap these positions over by multiplying both sides of the equation by x and dividing both sides by 5. This one is slightly different, as we've not just got x, we've got x plus 1. So writing this out, my particular approach would now be taking the confidence to say, well, I'm going to multiply both sides of this equation now by x plus 1 and divide by 5. Y minus 1 divided by 5 is equal to x plus 1. You can multiply this out and do a lot of factoring and tidying. It's entirely up to you. When I say factoring, more division. At this stage, I'm simply going to leave it like this and subtract 1 from both sides. So y minus 1 divided by 5 minus the 1, just here, is equal to x. Again, if you wanted to combine this, this is now negative 5/5. So we'd have y minus 6 over 5 is equal to x. And that's just basic fraction works. Instead of writing this as negative 1, I've written it as negative 5 over 5 and combined these two fractions. Okay, let's look at this one just here. So this one just here, there is absolutely no difference. Just because we have a y squared term in, we're making x the subject. So all we would do here is get exactly the same, but we'd have y squared minus 6 over 5. The issue comes with the next one though. We have now a squared term, and here we've got x squared plus 1. So y minus 1 over x squared plus 1. Remember, this is coming as a quantity. I can't just do something with a 1, just get rid of it. So exactly the same, I'm going to multiply both sides of the equation. Remember, every time I'm just looking at methods or techniques to get x's on one side, numbers on the other. So we'll have y minus 1, and I'll do this step by step, is equal to 5 lots of x squared plus 1. Dividing both sides by 5, y minus 1 divided by 5 is equal to x squared plus 1. All I've done here is just shown you an additional step. I'm multiplying by this quantity divided by the 5. So y minus 1 divided by 5 minus this 1 gives me now x squared. So I'm making x the subject, not x squared. What I need to do is take the square root. Whenever I take the square root, I'm always going to have a plus or minus, as discussed previously. So y minus 1 divided by 5 minus 1 is going to give us x. So I've got two solutions, or potential solutions, a positive and a negative. You might want to tidy this up and write this now as y minus 6 divided by 5 is equal to x. So that now is expressing x in terms of y, or if you like, making x the subject of the equation. Okay, let's move on and look at some more. So you can see these techniques are very similar. All we're doing is simply solving an equation, but we don't have an end numeric value. We have now an equation expressed in terms of other unknowns or variables. In question 4, we're asked to make p the subject of the following equations. So in A, we've got q minus 3 is equal to p squared. It doesn't matter that p squared is on the right hand side, it could now be on the left hand side. So I could simply write this. This is p squared, so I need to take the square root. The square root now is the inverse operation to squaring. Whenever I do that now, I get a plus or minus. So we can say q minus 3 now is equal to p squared. P is equal to plus or minus the square root of q minus 3. This is not correct. Plus or minus root q minus 3. It is the root now of all of this. It's the root of this quantity, not just the q term, it's for q minus 3. Okay, this one we need the cube root. Now with a cube root, we only have now a positive answer, or if you like, a negative answer. We only have one. We don't have plus or minus. So for example now, if I have 1 times by 1, that's going to give me 1. If I have negative 1 times by negative 1, that's negative, sorry, it's positive 1. I'm trying to make a thing here. So you can see that if I take the square root of positive 1, I get plus or minus 1. But if I have now negative 1 multiplied by negative 1 multiplied by negative 1, this is going to give me negative 1. So if we took the cube root of negative 1, it would now only give us one solution. So for example, if I did now negative 1 times by 1 times by negative 1, well, this is going to give me positive 1. So we can see, not that, in fact, let's make a better example. That's a very poor one. Let's just, because we wouldn't be taking the cube root, let's just get rid of those. So that's, I think that's what I was trying to get at. If we take the cube root of 1, that would be a better example to show, we're not going to have now a plus or minus answer. So here all we're going to have now, and I could write this two different ways. I could write this as the cube root now of q minus 3, or using index notation we could say that this is q minus 3 to the power of 1/3. I prefer this particular notation. It's entirely up to you. In the same way we could have had now the half power for this positive quantity here. Okay, let's look at the next one. We're making p the subject. What we need to do is square both sides of this equation. We've got the square root of p is equal to the quantity q minus 3. So what I want to do is square this. So squaring both sides, we'd have now q minus 3 all squared. If you want to look at this the other way, this is p to the 1/2 power is equal to q minus 3. What I've done now, in order to just get p, is raise this to the 2nd power, or if you like, the reciprocal. So I've got to do that to both sides. If we multiply these, we just get p, or p to the 1st, and that gives me q minus 3 to the power of 2. So all I'm doing is the inverse operation. Okay, let's look at the next one. Okay, what we have here is 2/5 of p cubed is equal to q minus 3. Very similar to these ones. What we've got though is a coefficient, a number multiplied by p cubed. At this stage, what I can do is multiply by 5 and divide by 2. I would prefer it if you saw that you were dividing both sides of this equation by 2/5, which is the same as multiplying by 5 over 2. So what we'd have now is 5 over 2, the quantity q minus 3 is equal to p cubed. All I've done is simply now, if you like, divided both sides of the equation. If that was 2, you'd be fine with that. It isn't, it's 2/5. Dividing by 2/5 is multiplying by 5 over 2. You could multiply both sides by 5, divide by 2. It's entirely up to you. So at this stage, all I need to do is take the cube root of both sides. So it's the cube root of all of this, 5 over 2 q minus 3, and that's equal to p. Remember, it's not plus or minus as it's the cube root. If we have now even powers, 2, 4, 6, 8, and so on, we do have a plus or minus answer. If we have odd powers, it's just now either a positive or a negative, not both. Okay, let's do this one right here. So this time we've got now 2 lots of p plus q is equal to 3. I could expand out, or I could simply divide both sides of the equation by 2. So 2 lots of p plus q is equal to 3. Dividing both sides of the equation by 3, I've got now p plus q is 3 over 2. It doesn't matter that this is not a whole number. I've just simply divided both sides by 2. So making p the subject, it would be 3 over 2 minus the q. So all I'm trying to do is get p isolated. We want to express p in terms of q. This is p in terms of q. P is 3 over 2 minus q. So when we say in terms of q, we can have what we call a constant, which is just a number. Every term doesn't have to have a q in it. Right, this one just here, exactly the same. But of course, at this stage, we're going to be adding q. It's exactly the same process, but instead of subtracting at this stage, we would add. Right, let's look at this one right here. So this one right here, we've got very similar. We've got two lots of q minus p divided by 5 is equal to 3. What you'll notice with this video and worksheet, it builds on previous questions to iron out any misconceptions by showing what you should do at each stage if you incorporate a new part to an equation. So multiplying both sides by 5, we got two lots now of q minus p is equal to 15. What you could have done again is divided by 2/5, entirely up to you. The way that this fraction's written would suggest that we multiply both sides by 5. It really doesn't matter. What we'll see is that q minus p now is going to be equal to 15 over 2. I want p to be the subject. We actually missed one here. It doesn't really matter. We'll do it with this one. I'm going to add p to both sides. So q is equal to p plus the 15 over 2. Subtract 15 over 2 from both sides. Q minus 15 over 2 is equal to p. And now we've made p the subject of the equation. Right, let's have a look at the other ones. This one just here. Right, with this one, nice and straightforward. We could divide both sides of the equation by 2. So we could write that p plus q is equal to now 5q minus 1 divided by 2. At this stage, all I need to do is subtract the q. 5q minus 1 divided by 2 minus q. What we can see here, though, is that we've got now a q in the numerator and we've got this q here. It doesn't look as tidy as it could do, so we could now combine the fractions and we could write that this is p. We've got 5q minus 2q, which is 3q minus 1 divided by 2. So that's what we have. All I've done is combine this. This is now 2q over 2. So 3q minus 2q over 2 is of the 5q over 2 minus 2q over 2 gives you 3q over 2. Right, this one here, exactly the same as before, but at this stage we would have now that p squared is equal to 3q minus 1 divided by 2. So just consider the only difference between these three is now our power of p. So we would simply write that p is equal to plus or minus the square root of 3q minus 1 divided by 2. Of course, you could write it as p is equal to plus or minus the square root of 5q minus 1 divided by 2 minus q. I would expect, though, you would want to tidy the fraction up. Here, instead of square rooting, we would square both sides. So if we had now that root p, so root p is equal to 3q minus 1 divided by 2, p would be equal to the quantity 3q minus 1 divided by 2 all squared, as we're squaring both sides of this equation. Okay, let's look at these. Right, with these ones now, we've got fractions. We could cross multiply. Now, cross multiplying is fairly straightforward. The way I'd like to deal with this one, though, is just to consider the lowest common multiple and multiply both sides of the equation by that. The lowest common multiple of these two fractions is 4. If I multiply both sides of the equation by 4, 4 over 2 will give me 2. 4 over 4 will cancel off. So what I'll have is 2 lots of the root of p plus q is equal to 5q minus 1. All I've done is multiplied here by 4. 4 over 2 is 2. I want to make p the subject. At this stage, I'm going to divide both sides of the equation by 2. As stated before, you could expand it out. I'll do it both ways. So root p plus q is equal to 5q minus 1 divided by 2. I only want p on the left-hand side, so I'm going to subtract the q. 5q minus 1 divided by 2 minus q. All I do at this stage is square both sides of the equation. 5q minus 1 divided by 2 minus q all squared. Now that isn't as tidy as it could have been. But of course I can just tidy this up exactly the same by writing this now as a common denominator here. So this would be negative 2q. So it'd be 3q minus 1 over 2 all squared. If you wanted at this stage, you could have multiplied this out. So 2 root p plus 2q is equal to 5q minus 1. Subtract the 2q from both sides. 2 root p is equal to 3q minus 1. Divide both sides by 2, 3q minus 1 divided by 2, and square both sides of the equation. 3q minus 1 over 2 all squared. So if you're more comfortable doing it this way, that's perfectly fine. With this one here, all we would do is multiply now both sides of the equation by 6. There would be no difference to what we've done in terms of the process, but if I multiplied both sides by 6, that's the lowest common multiple. So I'd have 3 lots of root p plus q, and then over here I'd simply have the 5q minus 1, and I could deal with that in exactly the same way as we've just looked. This next one is slightly nastier, as I've got to find the lowest common multiple of 3 and 4. That's 12. So if I did 12 over 3, that would give me now 4 lots of the root of p plus q. And if I multiplied this one by 12, that would give me now 3, and we'd have 5q minus 1. At this stage, I am going to expand out, and I'm going to write 4 lots of the root of p plus 4 lots of q is equal to 15q minus 3. I'm going to subtract both from both sides of the equation, 4 lots of q. So we get 4 root p is going to be 11q minus 3. Just remember, I'm constantly trying to get back to just having p on its own over here. Dividing both sides of the equation by 4, 11q minus 3 divided by 4. And then I'm going to square both sides of the equation. So p is going to be equal to now the quantity 11q minus 3 over 4 all squared. And that will give me now p in terms of q. Lots of steps, nice and straightforward, and all we're doing is doing exactly like we would if we were solving an equation with unknowns on both sides. Right. Question 5. The equation v squared equals u squared plus 2as is used in physics. This is another one of the constant acceleration equations. We're asked to write down the subject of the equation. The subject here is not v, it's v squared. So we got v squared as the subject. We're asked to make v the subject of the equation and explain why there are 2 possible answers. V, taking the square root of both sides as we got a square term, will be plus or minus the square root of u squared plus 2as. And we could state now that there is a positive and negative solution. This is velocity, and velocity has magnitude, which is a size, and also direction. So for example, if you're standing here and you move along the x-axis, we could move now with a velocity of 3 meters per second as we're moving in the positive x direction. If we moved in this direction 3 meters per second, this is in the negative direction, so it'd be negative 3 meters per second. The magnitude of this is the same, but the direction differs, and this is where you get your plus or minus value. Okay, in part C we're asked to make u squared the subject of the equation. Well, that's easy. We just simply need to, isolate this term. So I need to subtract this expression from both sides. V squared is equal to u squared plus 2as. So v squared minus 2as is equal to u squared. And that now is making u squared the subject. Hence, make u the subject of the equation. So in part D, it's telling me to use this, and all we can write is u is equal to plus or minus the square root of v squared minus 2as. As now this is a squared term here, and I need to take the square root to make u instead of u squared the subject. Okay, now in part E we need to make a the subject. So I want all the terms with a on the right hand side, anything without on the left hand side. So we'll have v squared minus u squared is equal to 2as. I want to make a the subject. This is saying that 2 multiplied by a multiplied by s is equal to v squared minus u squared. All we need to do to isolate that term a and make it the subject of the equation is now divide by 2s. All we've done here is simply now divided by what it was being multiplied by. So a is equal to v squared minus u squared over 2s. In part F, state without any further working what the equation would be when s is the subject. All we would do differently, instead of dividing by 2s, we would divide by 2a, because then that would leave us s as the subject. So v squared minus u squared over 2a is going to be equal now to s. So instead of dividing by 2s to make a the subject, we've divided by 2a to make s the subject. Right, okay. In question 6, we're asked to make a the subject of the following equation. Okay, so things are going to start getting harder here, and we're going to need to start factoring. So on the first one now, all I'm going to do is get everything on the left-hand side with an a in it, everything without on the right-hand side. So 3a plus b is equal to a plus 2b. So I'm going to subtract a from both sides and subtract b from both sides. If I do that, I'm going to have now 2a is going to be equal to 1b. So all I've done here is now subtracted a and subtracted b from both sides of this equation. Remember, all I'm looking to do is get a's over this side and b's over this side, or anything without an a on the right hand side. 2a is equal to b, so a is equal to b divided by 2. Nice and straightforward. Okay, here I'm going to multiply both sides of the equation by 2 to clear the fraction. So we'll have now 3a plus b is equal to 2 lots of a plus b, 2b, sorry. All we've got here differently is that this quantity is divided by 2. I'm going to expand the brackets. 3a plus b is equal to 2a plus 4b. I want a's on the left-hand side, so I'm going to subtract 2a from both sides, which leaves me 1a, and I'm going to subtract b from both sides, and that's going to leave me 3b. So a is equal to 3b. I'm sure if these were numbers, there would be no problems in solving them, but the fact that we're dealing with different variables or constants in some cases, or unknowns if you wish, it makes it slightly more challenging. Okay, this one here, very similar, but we're going to clear the fractions by multiplying both sides of the equation by 10. That's the lowest common multiple. So if I do that, 10 over 2 is 5, so we'll have 5 lots of 3a plus b, and that will be equal to, now 10 over 5 is 2 lots of a plus 2b. So expanding out, we're going to have 15a plus 5b is equal to 2a plus 4b. Subtracting 2a from both sides and subtracting 5b from both sides, we get 13a is equal to negative 1b. So a is equal to negative b divided by 13, or if you like, a is equal to negative 1/13 of b. Either way round, same value, just different ways in which we can write it. Okay, let's now look at the next one. Here we have now a in the bracket and we have a on the right hand side. This time I'm not going to divide both sides of the equation by 2. What I want to do here is expand it out. You could divide both sides of the equation by 2, but we'd end up now with subtracting fractions. So 2a plus 6 lots of b is equal to a minus b. So at this stage I want a's on the left hand side, so I'm going to subtract a from both sides. That leaves me 1a, and I'm going to subtract 6b from both sides, and that's going to give me negative 7b. As you can see now, what I'm doing is taking the a to the side where we've got more positive a's. If I subtracted 2a from both sides, I'd end up with negative a, and as I'm trying to make a the subject, that's going to be a bit of hassle. Right, this one is slightly more interesting because we've got a multiplied by b in the brackets. What I'm going to do now is go ahead, expand this out. Everything with an a in it, it doesn't matter that it's multiplied by b, goes on the left hand side. everything without an a goes on the right hand side. I've chosen the left hand side, you can choose the right hand side, entirely up to you. So 2 lots of a multiplied by b minus 2c is equal to a minus b. I'm going to subtract this a from both sides. That gives me 2ab minus a. And now I'm going to add the 2c to both sides. 2c minus b. So I've added a to both sides. And I've subtracted a from both sides. Let's write that clearly. Subtracted a and added now 2c. At this stage, we need to employ a different technique. I've got a, b and a. This is where a new skill comes in, and we refactor this. We take the common factor of a out, so that's going to leave me 2b minus 1 is equal to 2c minus b. So all I've done is expanded out, collected terms with a on the left hand side, collected terms without a on the right hand side. We've got a multiplied by this quantity after factoring. So if we want to make a the subject, we divide by that quantity. And that is a much more challenging rearranging problem. So all I've done here is factored out the a. A is common to both expressions. We can take that out. Right, let's look at the next one. 2 lots of a minus c is equal to b plus a multiplied by d. So again, we've got a multiplied by d. Let's expand the brackets. 2a minus 2c is equal to b plus ad. That's a term in a, that's a term in a, so I want them on one side. I'm going to subtract this ad from both sides. So we have 2a minus ad. Then I'm going to add 2c to both sides. 2c plus b. That now allows me everything on the left-hand side to have a term in a, and I'll just move this over, so I'm going to do it a different way in a moment. So let's just move that there. And again, I can factor a out here. So if I take the common factor of a, that leaves me 2 minus d is equal to 2c plus b. I just want a, so a multiplied by this quantity is 2c plus b, so I'm going to divide both sides of the equation by the quantity now in the brackets. 2c plus b divided by 2 minus d, and that is done. You might have got a different answer, because what I could have done here is now subtracted b from both sides and subtracted 2a from both sides. I chose the left-hand side to collect my a's. If you chose the right-hand side, you'd have negative 2c minus b is equal to ad minus 2a. Factoring this, negative 2c minus b, taking a out, a d minus 2. Dividing by d minus 2, negative 2c minus b divided by d minus 2 is equal to a. These expressions, whilst looking different, are in fact the same. If you put some values in, if you chose B, C and D to be 1, 2 and 3, you'll get exactly the same. It just goes, it's just a different way of writing it. With this one, you could now multiply through by the negative 1 and that would give you exactly the same. They are now the same. Okay, right, let's look at this one just here. This now is c multiplied by a minus d is equal to b plus a multiplied by d. We want a as the subject. So expanding out, I could write this as ca or ac. Minus cd is equal to b plus a multiplied by d. Again, I'm going to collect the terms with a on the left-hand side. ac minus ad. And collect anything without now an a on the right hand side. B plus c multiplied by d. A is common here. We factor it, c minus d, and that's equal to b plus c multiplied by d. I simply divide through by the content of the bracket, b plus cd divided by c minus d, and that has made a the subject of the equation. Okay, let's do the next one. So these are far more challenging, but again, we're simply trying to isolate terms in a on the left or the right and terms without on the other side. So h, a multiplied by d minus d squared is equal to b minus 3ac. We've got a term in a here, a term in a here. I'm going to add this to both sides. So what we'll have is 3ac plus a multiplied by d is equal to, and adding the d squared to both sides, b plus d squared. Factoring the a 3c plus d is equal to b plus d squared. So all I've done now is just factor the a out. A is common to both, we can take it out, and we divide through by the content of the bracket. So 3c plus d. And that now is making a the subject. Okay, let's just do the last one. AD multiplied, now a multiplied by d minus d squared is equal to bc minus 3ac squared. Term in a, so a, and I'll write this, add in this one on, 3ac squared plus AD is equal to BC plus D squared. Everything on the right hand side does not have an A in it. Everything on the left hand side does. We factor the A out. 3C squared plus D is equal to BC plus D squared. Dividing through, A is equal to BC plus D squared divided by 3c squared plus d. So again, a lot more challenging, but hopefully now you have the skills to work through a question like that. Okay, let's just finish off now with a couple more. These are the last questions. We're going to make x the subject of the following equations. So at the moment we've got x divided by 3 minus 1 over z is equal to y. So writing this out, x divided by 3 minus 1 over z is equal to y. X is the subject of the equation, so everything on the left with an x, everything without on the right. So I'm going to add this fraction to both sides. X divided by 3 is equal to y plus the fraction 1 over z. I can see x is divided by 3 or multiplied by a third, so I need to do the inverse of that, as we've been doing throughout. When we're doing the inverse, we're just doing the opposite operation. Multiply both sides by 3 and we're done. Okay, this one right here, slightly more challenging. 1 over x minus 1 over z is equal to y. So straight off we're going to start in the same. 1 over x is equal to y plus now 1 over z. At this stage, I could simply now divide both sides of the equation by this quantity and multiply by x. So I could write this now as 1 over y plus 1 over z is equal to x. And I have made now x the subject. The question might want this written as z over yz plus 1 is equal now to x. If they do, you can go all I've done here is combined the fractions by finding the common denominator. If we consider now y, this would be zy over z, and then we'd multiply through by the numerator. If you're dividing by a fraction, you're multiplying by its reciprocal. Alternatively, at this stage, what you could have done, and I'll write it just here, 1 over x is equal to, and combining these, we'd have now y multiplied by z plus 1 all over z. If we're at this stage right here, we can simply invert the fraction, write this as x over 1 is equal to the reciprocal now of yz plus 1. I actually prefer to do it in this manner, unless asked to simplify. Okay, let's do the next one. So what we've got now is 1 over x minus 1 over z is equal to 1 over y. I can write this now as 1 over x, adding both to both sides for 1 over z, 1 over y plus 1 over z. So at this stage, I could just take this quantity here and divide both sides. So I could write it now as 1 over 1 over y plus 1 over z is equal to x. As we saw before, we're just swapping positions by dividing both sides of the equation by this quantity and multiplying by x. You might be asked to make this look a bit prettier, and you could have combined these fractions. I'm just going to write now that this is going to be yz over z plus y is equal to x, because all I've done here is combine these fractions, multiplied this one by z, multiplied this one by y, and got the common denominator now, which is yz. So if we got 1 over that, then the yz can come there. If you're not happy with that, at this stage we'll pick it up and show what I've done. So common denominator is going to be y multiplied by z. I need to multiply the 1 by the z, I need to multiply this one by the y, and we end up now with this scenario. We can invert the fractions, so x over 1 is equal to yz over x plus y, z plus y, or y plus z, really doesn't matter, and that now can of course just be written as x. So yz over y plus z. So lots of different approaches, but essentially we're just now using the inverse operation to undo this process. So there's an hour, just gone over an hour. I'm going to stop there, but hopefully that's given you now the skills that you need to rearrange equations, even if they get a little tricky.